Okay, hello. So this is a video from section 1.4. And in section 1.4, we are talking about quadratic equations and solving quadratic equations. Okay, so I quickly want to give the definition of quadratic equation. So quadratic equation is equation in form ax squared plus bx plus c equals 0, where a, b, c are real numbers. And a cannot be equal 0. So a couple ways of solving quadratic equation. The first method which I'm going to introduce, it will be solving quadratic equation using quadratic formula. So here we'll focus on solving quadratic equations using quadratic formula. So quadratic formula. X equal negative b plus minus square root b squared minus 4ac divided by 2 times a. Any quadratic equation can be solved with quadratic formula. Just remember, if you want to use quadratic formula, you will leave your quadratic equation in a standard form, which means you only have a 0 on the right side. Now the quantity under square root b squared minus 4ac. So this quantity, which you see under square root, is called the discriminant. And the discriminant can give you very useful information, which can tell you how many solutions your quadratic equation will have. So b squared minus 4ac, this is discriminant. And couple information about the discriminant. So if the expression b squared minus 4ac, if the discriminant is greater than 0, which is positive, so there are two unequal real solution. That's why in quadratic equation, quadratic formula, you see that plus and minus, because most of quadratic equation have two solutions. Now, if the discriminant is equal to 0, so there is a repeated solution. Technically, we can say that there is one solution. Many times we call it repeated solution. Or double root. So one solution, repeated solution, because we may say that x1 equal 5 and x2 equal 5. And that repeated solution sometimes we also call double root. Okay. Now the third property of discriminant, if discriminant b squared minus 4ac is less than 0, there is no real solution. So there's no real solution. However, if discriminant is negative, you can find solution in complex number system. So you can only solve the equation in complex number system. So you will continue solving when the discriminant is negative, only if they will say in the problem, like find all solutions. So then we'll use that I imaginary unit. So only if the problem say find all solution. If in the problems they will say find real solution, your discriminant is negative, then you will just stop because there is no real solution. So next what I want to do a couple examples of how to use quadratic formula. So solving quadratic equations. With the quadratic formula. Okay, so the first one which we're going to solve, it's 2x squared minus 5x equal negative 3. So we're not ready to use the quadratic formula because you need to rewrite this equation in standard form. The equation in standard form. So standard form means ax squared plus bx plus c equals 0. So we're moving everything to the left side of the equation and you only have a 0 on the right side. That's a standard form. So in this case, I'm going to add 3 to both sides to get that 0 on the right side. So we have 2x squared minus 5x plus 3 equals 0. And now we're ready to use quadratic formula. So now you can use quadratic formula. Okay. So 2, it's a. So coefficient in front of x squared represents a from quadratic formula. Coefficient which you see in front of x, that's b from quadratic formula. And the number which stands by itself, it's c. So quadratic formula is x equal negative b plus minus square root of b squared minus 4ac divided by 2 times a. So we're going to substitute. So we have negative b, which is negative 5, plus minus square root b squared, which is negative 5 squared, minus 4 times 2 times 3. And everything has to be divided by 2 times a, which is 2 times 2. So a lot of operation in quadratic formula. What I recommended to calculate that discriminant first. Okay, so this is the discriminant. So I will quickly on the side will calculate that negative 5 squared minus 4 times 2 times 3. So this is just 25 minus 4 times 2 times 3, it's 24. And this is equal 1. So I see that the discriminant, because this is the discriminant, is greater than 0. So we will have 2 real solutions, 2 unequal real solutions. So let's continue. So we have x equal negative and negative 5 will give you positive 5 plus minus, and that discriminant we simplify, we end up with 1. So I'm going to replace that with 1. Divide by 2 times 2, which is 4. So the first solution, I'm putting index 1, will be 5 plus square root of 1 divided by 4. So this is just 5 plus 1 divided by 4. We're getting 6 over 4. Reduce the fraction by 2, which is 3 over 2. So this is our first solution. The second solution, I'm going to put index 2. That's when I'm going to perform subtraction. So that would be 5 minus square root of 1 divided by 4. So this is just 5 minus 1 divided by 4. We're getting 4 divided by 4, which is 1. So we end up with 2 unequal real solutions. So we have 2 solutions. I will just write this down that the solution set is, and we have 1 and 3 over 2. So like you see, it's very helpful to calculate that discriminant at the beginning, so you will know exactly what type of solution you will end up. I would like to do one more problem by solving quadratic equation with quadratic formula. This one has fractions. Oops. So here B, we have 3 over 4 x squared minus 1 over 4x minus half equals 0. So this quadratic equation is already in standard form. However, you have fractions. So using quadratic formula with coefficients being fractions, I not recommended. So we don't want to have a fraction. So what you want to do here first, I want you to first find lowest common multiple of the numbers which you have in denominator. So we have 4 and 2. And multiple of 4 and 2, the lowest one will be 4. So is 4. When you find that lowest common multiple, the second step will be multiply both sides. So multiply both sides of the equation by lowest common multiple. So in our case, by 4. By applying those 2 steps, our quadratic equation will become quadratic equation but without fractions. So I'm going to multiply both sides by 4, which is our lowest common multiple. So the left side of the equation we multiply by 4. And the right side of the equation we're going to multiply by 4. So here I will need to distribute 4. So we have 4 times 3 divided by 4x squared. So number multiplied by fraction means multiply only numerator by that number. Then we have minus 4 times 1 divided by 4x minus 4 times 1 divided by 2 equal 4 times 0, which is 0. So now we're just going to simplify. 4 cancel, so we end up with 3x squared. 4 cancel, so we end up with negative 1x. And 4 times 1 is 4, divided by 2, that will give us negative 2, equals 0. And now this is nice quadratic equation. This is standard form, definitely, of quadratic equation. So we're ready to use the quadratic formula. 3 will be A, negative 1 will be B, and negative 2 will be c. So let's use quadratic formula. So quadratic formula. X equal negative b plus minus square root b squared minus 4ac divided by 2 times a. Okay, so I'm just going to plug it in. Negative b, it's negative 1, plus minus b squared minus 4ac. So we have negative 1 squared minus 4 times 3 times negative 2. So this is under square root. And everything divided by 2 times a, which is 2 times 3. Simplify. Again, always I recommend it to simplify the discriminant. Calculate this one first. So on a side, I'm just going to calculate that discriminant. Negative 1 squared minus 4 times 3 times negative 2. So we're getting here 1 plus 2 negatives gives you plus. So 4 times 3, we're getting 12 times 2, 24. So the discriminant, it's 25. So discriminant is greater than 0. So again, we will have 2 unequal real solutions. So I'm going to replace that discriminant with 25. So we have x equal 2 negatives will give you plus, have 1, plus minus square root of 25, divide by 6. Simplify, this is 1 plus minus 5 divided by 6. So we already know that we will get two solutions. So the first one I'm going to mark with index 1. And to get the first solution, I'm going to perform addition. So I have 1 addition in numerator. So this is 1 plus 5 divided by 6. 6 divided by 6, we're getting 1. Second solution, I'm going to perform subtraction. So we have 1 minus 5 divided by 6. We're getting negative 4 divided by 6. Always reduce the fraction. So divide numerator and denominator by 2. And we're getting negative 2 over 3. So two solutions. The solution set, which means two solutions you're going to list it. It's negative 2 over 3 and 1. So those two numbers will satisfy the given quadratic equation. Next method of solving quadratic equation is a factoring method. So we also can solve quadratic equation using factoring method. So factoring method, the one which I'm teaching, I call Berry method. There's many ways to factor quadratic equation, and I will just stick to the one method. Do not confuse. Berry method, sometimes they call it AC method. Okay. So we'll do a couple examples. I'm going to explain the AC method based on the example. So we need to solve a quadratic equation by factoring. Okay. And the first one, I have x times x minus 8 plus 12 equals 0. So, of course, first what you want to do, you want to remove the parenthesis. So first, remove the parenthesis. So we're going to distribute that x. That will give you x squared minus 8x plus 12 equals 0. And we're going to start solving because this is standard form. So when we have standard form of quadratic equation, that means you're ready to factor. So we have standard form of quadratic equation, means we're ready to factor. Not every quadratic equation can be factored, so be aware of that. If you cannot factor quadratic equation, then try to solve using quadratic formula. So standard form, in this case, a will be 1, that's the coefficient in front of x squared. B will be negative 8, coefficient in front of x. C, it's always number by itself, which is 12. So AC method. Step 1, multiply A times C. So in our case, we're going to multiply 1 times 12, we're getting 12. So the product of A times C is equal to 12. Step 2, we're going to find two integers. So find two integers, which product equal to AC, and they sum equal to coefficient B. Okay, so I'm looking for two integers, which product it's equal to A times C. So product is multiplication. So I will just use for multiplication that, so we're not getting confused with x. In our case, A times C is 12. Also, the same two integers by addition has to give you the coefficient B. So coefficient B is equal to negative 8. Okay. So of course, those two integers, they have to be the same. So this is where we have to start checking what's going to work. Here, negative 6 and negative 2 will work. So negative 6 times negative 2, 12, and negative 6 plus negative 2, we're getting negative 8. So when you find those two integers, you're going to create two factors. So create two factors. That way, ax plus first integer times ax plus second integer. Okay, so in our case, we have a, which is 1x plus first integer, which is negative 6, times 1x plus second integer, which is negative 2. Okay, I'll just put that equals 0, equals 0. So let's just simplify that. So this is just x minus 6 times x minus 2 equals 0. So technically, we factor quadratic equation. I would just give a note. If coefficient A is not equal to 1, you need to factor greatest common factor from each parenthesis and I will put it and ignore it. We're going to do the problems like that. Okay, so in our case, a is equal 1, so we don't need to worry about that. So step 4 will be solve two equations. Which means ax plus first integer equals 0, and the second equation will be ax plus second integer equals 0. So in our case, we're taking this x minus 6 equals 0 and take the second parenthesis, or x minus 2 equals 0. So you're solving two equations, okay? We call that, we're using here zero product property. So to solve this one, we're adding 6 to both sides, we're getting x equals 6. Here we're getting x equal 2. So we have two solutions. So the solution set is 2 and 6. So two solutions. Of course, you can always check your work. You can plug in those numbers into our original equation and check if that makes sense. So I have one more example of how to solve quadratic equation by factoring when the leading coefficient, which is when a it's not equal 1. So b, so solve by factoring. And this is the example when a is not equal 1. Okay, so I want to show you what happened. So we have 2x squared minus 5x minus 3 equals 0. So we are ready to factor because the equation is in standard form. Okay, so again, standard form, it's ax squared plus bx plus c equals 0. So I'm going to write down that a is coefficient of x squared, which is 2, b is coefficient of x, negative 5, c it's a number which is by itself, negative 3. So step 1, we find that product a times c. So we have 2 times negative 3, we're getting negative 6. Step 2, we're looking for two integers which product is equal to a times c, which is negative 6. And the same two integers by addition has to give you coefficient b. So coefficient b, it's negative 5. And here we have to just check what's going to work. Negative 6 and 1 will work. So when you find those two integers, you're ready to move to step 3. You create two equations, ax plus first integer times ax plus second integer equals 0. So in our case, a is equal to, so we have 2x plus negative 6 times 2x plus second integer, which is 1, equals 0. Simplify that. So this is just 2x minus 6 times 2x plus 1 equals 0. And this is the situation which I was talking about. A, it's equal to. Okay, so A, it's not equal to 1. When that happens, we need to factor, if possible, greatest common factor from each group. And then I said, and ignore it. And you will see why I'm saying that. Okay, so in the first group, the greatest common factor is 2. I'm going to factor 2. So we have x minus 3 times, from the second group, greatest common factor between 2 and 1 is just 1. So if the greatest common factor is 1, just copy the parenthesis, and that's equals 0. So why I'm saying that you're going to ignore that greatest common factor, because technically what we're doing, we're going to divide both sides by GCF, in our case by 2. So I'm dividing the left side by 2, I'm dividing right side by 2. Like you see, this one will cancel, and we end up with x minus 3 times 2x plus 1 equals 0. So now this is correct. We factor correctly. And now use zero product property to solve. Which means you're solving two equations. X minus 3 equals 0. And you're solving the second equation, 2x plus 1 equals 0. And we're getting x equals 3. Here we'll subtract 1 from both sides. So we're getting 2x equal negative 1. Divide both sides by 2. We're getting x equal negative 1/2. So we have two solutions. So the solution set is negative 1/2, 3. So two solutions. So this is how we solve quadratic equation by factoring. AC method, sometimes called Berry method. Again, be aware that not every quadratic equation can be factored using AC method. We're using that AC method when you have nice quadratic equations. Like you see, the coefficients are integers, so it's easy to find those factors. Next one is solving quadratic equation using square root method. So I want to talk about square root method and provide you a couple examples. So another way to solve quadratic equation will be square root method. So square root method, I would say use it when you don't have x in quadratic equation. So technically, use it when your quadratic equation looks like this. Ax squared plus c equals 0. Or ax squared equal negative c. I'll put this way, equals c. So that's when you're going to use it. Like you see, there is no x. So steps to solve it. So steps to solve it. So first, what you're going to do, you're going to transform the equation such that the perfect square is on one side and a constant is on the other side. So you're going to transform the equation such that a perfect square okay, which is ax square expression, is on one side and a constant so here we're talking about constant c, and the constant is on the other side of the equation. That's step one. Second, use the square root property. To find a square root of each side. So this is what we're going to do. Let's say square root of 4. We just need to remember we'll have two solutions, positive and negative 2. Okay. So just remember that you have positive and negative solution. Okay. And the third step will be solve each resulting equation. Okay. So example, solve quadratic equation using square root method. Okay. And I'm going to say it in real number system. So we're not talking about imaginary numbers here. So the first one, A, we have x squared minus 16 equals 0. So like you see, we can apply that square root method because we don't have an x. So step one was transform the equation such that only perfect square is on one side of the equation. So perfect square is x squared. We want to isolate that x squared, so we'll add 16 to both sides. And you're getting x squared equals 16. When you got that, step two is use the square root property to find square root of each side, which means we're going to take the square root of the left side of the equation and square root of the right side of the equation. So the square root of x squared is just x, and square root of 16, it's positive 4 and negative 4. So we have two solutions. The first one it's positive 4 and the second it's negative 4. So don't forget that when you take the square root of positive number, always two solutions. So the solution set is -4 and 4. Okay, I have two more problems by applying square root property. B, we're going to solve this one. X plus 1 square equal 49. So this equation is asking you to apply square root property. I don't want you to distribute, I don't want you to FOIL, I don't want you to multiply x plus 1 times x plus 1. Just take the square root of both sides. So we're quickly going to take the square root of the left side, square root of the right side. So second power and square root, they undo each other. So we only have x plus 1 equal square root of 49. It's positive 7 and negative 7. So now when we have that, we're just going to solve two equations. The first one will be x plus 1 equal positive 7. And the second equation will be x plus 1 equal negative 7. Just solve each equation for x. We're getting x equals 6. And here we're getting x equal negative 8. So two solutions. Okay. And one more. C, we have x minus 3 squared equal negative 28. So here I want you to be careful, because if you would like to try to take the square root of both sides, yes, that will cancel. So you will end up with x minus 3. However, it's impossible to take the square root of negative number. So no solution here. We can't have negative under square root. Okay, so I would say there's no real solution. And I ask you to solve in real number system. So in real number system, this one has no solution. Okay. I just want to continue here. If they will ask you, if you will be asked to find all solutions. So that's a big difference, all solutions. So here we also talk about imaginary numbers, complex number system. So then you will continue. So then you will do x minus 3 equal positive negative square root of negative 28. And that will give you x minus 3 equal positive negative square root of 28i. Okay, and then you will solve two equations. X minus 3 is equal square root of 28i, and x minus 3 is equal negative square root of 28i. I just want to simplify that. Square root of 28, by the way, is the same as 4 times 7, which will give you 2 square roots of 7. So let me just change that. So we have x minus 3, it's equal to square roots of 7i. And here we have x minus 3, it's equal negative 2 square roots of 7i. So you will add 3 to both sides. In the second equation also you will add 3 to both sides. And that will give you that x is equal to radicals of 7i plus 3. That will be the first solution. And the second solution will be negative 2 radicals of 7i plus 3. Okay, we only do that when in the problems they ask you to find all solutions. So the last method of solving quadratic equation is solving by completing square root method. So this method is important actually when we'll talk about the circles. I'm going to explain how to use that method based off the example. So we're going to solve x squared plus 12x plus 2 equals 0. So of course, to use that method, you need to have equation in standard form, which means ax squared plus bx plus c equals 0. Okay. So step 1 is move constant to the right side. So move constant c to the right side. So in our case, we will need to subtract 2 from both sides. So that will give us x squared plus 12x equal negative 2. So this is the first step. Step 2, divide each. So divide each by coefficient a. So in our case, coefficient a it's 1. So technically what we need to do, we need to divide each by 1, which will give us exactly the same equation. So we have x squared plus 12x equal negative 2. So you're going to divide each by coefficient a only when a is not equal to 1. Okay, so technically that's when we're applying that step 2. Step 3, we're going to calculate b divided by 2. Okay. So in our case, b divided by 2, so b, it's 12. So this is b right here. So we have 12 divided by 2, we're getting 6. And I'm putting that in a cloud. It will make sense because this later will be in the parenthesis. So just save that. Step 4, add b over 2 squared to both sides of the equation. So we are right here. Our equation looks that way, x squared plus 12x equal negative 2. So let me calculate that b over 2 squared. So b over 2 was equal 6. Now we need to square it. So that will give us 36. So in our case, we're going to add 36 to both sides. So we have x squared plus 12x plus 36 equal negative 2 plus 36. So again, this is that b over 2 squared. Like you see, I added to both sides of the equation. Um, so what happened on the left side? On the left side, you have perfect square, which means you can factor easily that equation. Here, we will get just positive 34. So this is perfect square. We can factor. So this is complete square. So we're going to factor. So that will lead to step 5. Factor the left side, which means which always will be x plus b over 2 to a second power. You're going to see that. So to factor x squared plus 12x plus 36, this is the same as x plus 6 times x plus 6, which is the same as x plus 6 squared. So this is complete square. And like you guys see, this part, 6, going back, was your b over 2. Okay? So in this method, when you factor the left side, you always will end up with x plus b over 2. That always will be b over 2 squared. So x squared plus 12x plus 36, so this is the same as x plus 6 squared, equal 34. And step 6, solve for x using square root method. Which means we're going to take the square root of both sides. So we have x plus 6 squared equal 34. Just take the square root of both sides. So this is the square root method. And second power and square root cancel each other. We end up with x plus 6 equal positive and negative square root of 34. Okay, so square root of 34. We cannot really simplify that, so just solve two equations. X plus 6 equals square root of 34, and x plus 6 equal negative square root of 34. So we subtract 6 from both sides, and we're getting x equals square root of 34 minus 6. And the second solution will be negative square root of 34 minus 6, because also we'll subtract 6 from both sides. So the solution is that when we have two solutions and the answer is irrational numbers, sometimes we can just combine them and put it that way, that x is equal positive negative square root of 34 minus 6, which will represent those two solutions. So that was complete square root method. I have one more to solve it with complete square root method. And that will be the end of the section 1.4. So we have 2x squared plus 8x minus 15 equals 0. So step 1, we're going to move the constant to the right side. So we're going to add 15 to both sides. So we're moving constant to the right side. So we have 2x squared plus 8x equal 15. That was step 1. Step 2, we need to calculate that b over 2. So b, it's 8, divide by 2, we're having 4. Keep that in a cloud, because knowing this, you already will know what you will have in the parenthesis. Okay, I'm sorry. This is, before I will continue, this is different example, a little different. So here, our a is equal to, which is not equal 1, then what we need to do, we need to divide all by 2. So I need to divide each by 2 before I calculate b over 2. So we're getting x squared plus 4x equal 15 over 2. Okay. Now, my step 2, so that was step 2. I divide, just want to keep the same order. So this is step 1, and that was step 2, when I divide by 2. So now step 3, we can calculate that b over 2. So b over 2, b it's 4. We have 4 divided by 2, that will give you 2. Keep it in a cloud, that will be later in a parenthesis. So I already know that we'll have x plus 2 squared equals something. I already know that, just by knowing what is that b over 2 when we complete the square. So step 3, add to both sides b over 2 squared. So b over 2, it's 2. 2 squared, it's equal 4. So we're going to add 4 to both sides. So we have x squared plus 4x plus 4 equal 15 over 2 plus 4. So here you have a perfect square, which we can factor. So that will be step 4. And that will give you x always plus b over 2 squared equal 15 over 2 plus 4. 4 is the same as 8 over 2. So we have x plus, don't forget that b over 2 was equal to, so we have x plus 2 squared equal, we have 23 over 2. Okay, and now having this one, the last step, step 5, take the square root of both sides. So I'm taking the square root of the left side, square root of the right side, and we end up with x plus 2 equal positive negative square root of 23 over 2. And step 6, solve two equations. So we're solving x plus 2 equals square root of 23 over 2. And we're solving that x plus 2, it's equal negative square root of 23 over 2. So just quickly rationalize the denominator. So this is the same as radical of 23 divided by square root of 2. So multiply top and bottom by square root of 2. So that will give you square root of 46 divided by 2. So I will just rewrite that as x plus 2, it's equals square root of 46 divided by 2. Here x plus 2, it's equal negative square root of 46 divided by 2. Solve for x. So we'll subtract 2 from both sides. We're getting x equals square root of 46 divided by 2 minus 2. And here we're getting x is equal negative square root of 46 over 2 minus 2. So again, irrational solution, which means you can leave it as x equal positive negatives square root of 46 divided by 2 minus 2. So we have two answers. So that's it from section 1.4. Hopefully those additional examples will help you. Thank you so much.